Okay, recording has started.
Okay, perfect. Thank you so much. Well, thank you all for joining us and welcome to the Society of North Carolina Archivists Spring Lunch and Learn series, which is all about AI and archives. My name is Danielle Sharella. I'm an outreach archivist at the State Archives of North Carolina, and I also serve on the SCNA Education Committee with Marlise, who's here, which aims to provide programs like this to SCNA members. As a reminder, the call for proposals and workshops for the joint SCNA conference has been extended to February 13th. So be sure to submit your ideas by then. Today, I'm joined by Cal Lee. Cal is a professor at the School of Information and Library Science at the University of North Carolina, Chapel Hill, my alma mater, and a fellow of the Society of American Archivists. He teaches courses and workshops in archives and records management, understanding information technology for managing digital collections, digital curation workflows, and information ethics. His primary research focus is the long-term curation of digital collections. He's passionate about enabling information professionals and other stakeholders to successfully implement and sustain new digital curation practices. Today, Cal is going to provide an introduction to AI in archives. If you have questions throughout the webinar, please put them in the chat and we will answer them live at the end of the session. As you all have heard, this webinar will be recorded and the recording will be sent out via the SCNA listserv when it is ready after the presentation. And without further ado, I'll go ahead and pass it off to you, Cal.
Thank you very much. Thank you everyone for joining. So going to do my best to share some slides here. Whoops. Not now. My apologies. Slightly new interface for me, but I think this is working now. Okay, well, again, welcome everybody. I'm just going to talk a little bit about AI and archives and what we might mean and what the specific kind of tangible and practical implications of it might be. So I wanted to start out talking about what's, in some ways heretical given the language that we tend to use in archives of late, which is things like more product, less process, the idea that we need to sort of reduce and minimize the amount of human attention that is involved in certain parts of our processes. When we're dealing with born digital or digitized materials, that dynamic is quite different. Archivists often need to apply more processes to born digital records: integrity checks, metadata extraction, audit trails, characterization of files. But luckily, a lot of that work can be done either through or with software. And so that's a little bit about what we're going to be talking about today. This implies new archival workflows. Current digital curation functions involve all kinds of decisions that are based on patterns, right? Commonalities, differences, contextual relationships. And when we can identify those patterns, whoops, my apologies there. When we can identify those patterns, then we can potentially use algorithms and machine learning, as I'll talk about a little bit later, to address those patterns. And so that's kind of a through line of everything I'm going to be talking about, is regardless of what we decide to call AI or how we characterize it, ultimately it's about being able to identify detectable patterns that we can consistently use to perform certain kinds of tasks. And compared to analog materials, these functions that we engage in, whether it's appraisal, description, tend to be more iterative because we discover things about the materials as these actions are carried out. We conducted a project a few years ago called OSS ArcFlow, which provides examples from a number of different partner institutions of their workflows related to digital content, especially born digital materials, and how they kind of chain together these different tools to perform different tasks. So just a few examples of these kinds of tasks that are based on detecting patterns. We can look at scanning for potentially sensitive information. So anybody who's in the kind of bit curator world who's used that environment might have used bulk extractor or outside of that environment as well. And essentially it's just a set of sort of microservices, little tools that can run and find potentially sensitive and other kind of identifying information. And so if you run bulk extractor, it goes through and it can look through based on various patterns. What's a credit card number? What's an email address? What's a phone number? What's a URL? And then basically report those out to the person who's caring for those materials. And so this is, hopefully nobody is going to run screaming from the command line here, but this is what it looks like at the command line, where you can see the various kind of flags and parameters that you can set in order to run this tool. It then gives you this output of these text files that are about these different forms of output. And it takes the form, if you look there at the bottom, of these basic breakdown of an offset, where it shows you where in the materials you can find that pattern. It shows you the pattern, what it found that it thinks, for example, is a phone number, and then the context, which is the kind of text surrounding it. And so rarely would somebody be looking directly at these text files. They're usually going to encounter it in a way that some sort of software can pick up and use. So an example of that would be Bulk Reviewer, which Tessa Walsh introduced to the Bit Curator and larger digital curation community. And it's essentially a graphic user interface for conducting these same sort of tasks. So you tell it to scan a directory or a disk image, it runs, and then it reports out these things that it finds, right? A phone number, a credit card number, whatever it might be, and then you can make decisions about what you want to do about those patterns. We engaged in a project, a long time ago now, called Bit Curator NLP, which was funded, as was the Bit Curator and Bit Curator Access projects through the Mellon Foundation. And it was basically to develop software to run natural language processing tools to pull out things like named entities, names of people, organizations, and topic modeling, which I'll demonstrate just very briefly here. One of the big challenges for this work that we did with natural language processing, and it's really important to keep in mind when we're thinking about any of these sort of AI tools, is that most applications of natural language processing and other kinds of pattern detection tools are generally based on relatively consistent, clean collections, right? So if you see people reporting on some new algorithm that they've developed that does even better than the competitors, they usually run it against some corpus that's very cleaned up and standardized. It might be a whole set of news articles or something. Whereas obviously archival collections contain raw or packaged disk images, which are an entire computing environment on a disk. They can be all kinds of different file types. They can have limited or inconsistent metadata. So part of the messy work behind any of the aspects of this work of applying these kind of tools is to understand whether the data, the kind of materials that are in our collections, are actually ready to feed into those sorts of tools. So if I handed you a disk full of files, what would be the steps to actually apply, for example, natural language processing to the content? Well, here's one kind of flow of tools that you might potentially use. You'd start out by, let's say it was a disk image. You first have to be able to read the data off the disk. You have to be able to recognize the file system that's on that disk, right? So it kind of breaks it up into files or folders. You then have to identify individual files and extract the text out of those individual files and then feed it into these various tools, right? So for example, this is showing topic modeling, where the output from that raw text then allows you to kind of cluster different terms to see what kind of patterns you can identify. Another pass would be, for example, Spacey, which is a tool that we've done a bunch of work with to do named entity recognition, where you could identify people and places and organizations and things like that. So there are a number of different tools for doing text extraction. Textract is one in particular that we've done a lot of work with, where it basically goes into different file types and will extract text. If it's something that just looks like a picture, let's say it's a TIFF file, it might need to have OCR first, right? Do optical character recognition so you can pull the text out. And obviously you can add additional extraction tools as needed, depending on what kind of formats you're dealing with. There are a variety of different tool sets that have come out of teams that I've kind of led and worked with over the past decade. Here are some of them that obviously you can read more about in GitHub and download and play around with if you're interested. I'm just going to very quickly reference them and walk through them to identify some of these ideas of how we can detect patterns using these kinds of tools, right? So Bit Curator Access Web Tools is basically software that you can run on a server and then on the client side in your browser that allows you to navigate around a disk image, right? So a disk image is just a full copy of everything that was on a disk. It's not just copying the files off. It's essentially replicating the underlying storage of the disk. And that can have a lot of benefits that I won't get into right now, but one of the issues is then, well, then how do I access and interact with those disk images? So there are a number of answers to that, but one of them that we developed is this environment where basically you can just load up a disk image in your browser and then navigate through it as if it's a folder sitting on your own computer. And part of the idea is you do minimal processing. You're not doing all kinds of extraction of files and folders. You just have a disk image sitting there, and then somebody can navigate it using these sorts of tools, right? And so there's documentation obviously available on these tools if you're interested in learning more about them. This is the idea, if you were to visually walk through it, is that you could see here, oh, here's a bunch of different images, right? Disk images that you can interact with. You might interact with these ones. You might, for example, go into a USB flash drive and see that it has multiple partitions on it, meaning each one of those has its own file system. And then go in and see within that directory individual files, right? So obviously all of this is pretty straightforward. But part of how this links into most of what we're going to be talking about today is the use of things like text extraction. So pulling the text out of those files. So somebody in this situation could look at the text of the PDF file pulled out into their browser. But then they could also, based on SCNA, which identifies all these different named entities, people, facilities, organizations, dates, they can then essentially have it generate a view that shows them those named entities, right? That says, well, here's the name of a person, here's the name of an organization, which isn't the end of the process in most cases, whether it's for an archivist or for an end user. It's often as a starting point to do more inquiry and say, oh, I've identified this name of this organization, maybe I should do a search on that person. It's important to recognize that these tools out of the box, unless you do a lot of customization, are going to have errors, right? They might be, 85% say accurate on identifying entities. So you wouldn't want to give it as a definitive list of names, for example, in a corpus of materials, but it can be very, very useful for facilitating a lot of sort of processes. And so this is an example of, you've got a PDF file, and then you've got these things like geopolitical entities and dates and persons that are identified. And then you could, for example, do a search using something like the web access tool to then say, okay, I identified the name of this person. I'm going to do a search on that name and see if I can find it in a particular file, right? And there it appears. The other branch that we went with this tool was topic modeling. So topic modeling, the name is actually pretty deceptive because it suggests that somehow it's going to generate a set of topics for you. Topic modeling actually is much more bottom up than that, where it just shows you clusters of either words or documents that contain words and how close they are to each other sort of semantically. Do they use a lot of words in common? And then it's actually the end user's job to figure out, let's say, for example, you're using this in appraisal and you might determine, oh, a bunch of these are clustered around terms and ideas that appear in this person's personal life versus their work life. So maybe those are things that don't belong in this collection and should be, removed, redacted, marked in some special way. And so this is the idea of what you can see within topic modeling. You can move sliders around to decide what sort of visualization is most useful to you. Do you want to base it on frequency within the entire corpus, the uniqueness of that term within that particular collection? And this can help with various kind of insights and intuitions. And this is sort of more on the back end, the way these tools would work. If you're using them by exporting, for example, a bunch of named entities to then import into another tool, you'll basically just have this raw output that says this word appeared here, this word appeared here, and then you can use other tools on top of them. A final example I wanted to give, because these kind of have happened in succession, over time, is RATOM, which is a project we worked on between SILS and the State Archives in North Carolina, called RATOM, which was Review, Appraisal, and Triage of Mail. This was also funded by the Mellon Foundation. We were building off of work that we had done with BitCreator NLP and that the team at the State Archives had done on a project called Tomes. And we generated tools like LibRatom, which will libdraytime, this sort of set of tools that will start with a PST file, right, or an MBAX, but really a lot of what we focused on was the PST file, which is a sort of proprietary, fairly well documented, but really kludgy, definitely not preservation worthy way that a lot of email is stored. And so the idea was, how do you first just extract, the messy work that we don't usually want to talk about, which is just getting the stuff out of that format. And then once we've done that, how can we process it in ways that would be useful, using, again, tools like Spacey, which I mentioned before, which is that named entity recognition tool. One of the things that we worked on, again, with our partners is this iterative processing interface. So the idea would be that you could have certain things that are flagged either manually or by some of these tools. Like, for example, here are all of the named entities that the tools could identify. And then you can work through a collection of email by identifying things that you have flagged as, for example, record or non-record content, something that you want to have redacted. And the idea is that you can hopefully move up and down in the levels of aggregation, where you could identify, for example, a term or an entity that appears in one email message, and then say, oh, that actually really alerts me to the fact that I need to redact that or mark that as non-record for all of the email that contains that term. Because obviously item level processing at the human level is not what we're aiming for in general. Another thing we generated from a lot of this work is a set of Jupyter notebooks, so you can go in and basically kind of walk through how the code works without having to run all of these things locally when you're first discovering them and seeing how it works. This is, again, the iterative processing interface. I think I just doubled that slide, so my apologies. This would be the accounts view, where you would go into different email accounts and then navigate down into, within that individual account, what are the email, what are the folders, what are the individual messages, and then how might you, again, mark them as being, restricted, open, record, non-record content. And then there's an audit history, which of course is very important with a lot of these tools, to be able to tie it back to what actual practices and decisions this was informing. So is any of this stuff I just talked about AI? I don't want to dwell too much on that question, because there's a lot of debate around what we mean by AI. In a lot of ways, AI just means whatever pattern detection stuff that software does lately that really is amazing to us that we didn't think software could do, right? Because in many ways, things like spell checkers, autocomplete, spam filters, all kind of things that have been very well integrated into our computing lives aren't usually characterized as AI anymore, because they're not complicated and interesting enough anymore. So it's kind of a moving landscape. But the reason why somebody might not, for example, characterize a lot of that natural language processing tool application I used as AI per se is that it does rely on models, but you're not feeding back into the model as you're doing the work, right? It's not a dynamically updated and generated model. So I'd like to shift our attention to what almost everybody recognizes as AI, right? Is generally what you see people referring to when they're talking about artificial intelligence these days is machine learning. So what do we mean by machine learning? It means algorithms can generalize from data to new situations, so they can perform tasks that weren't specifically specified by the algorithm creator, right? It's not rules-based where you just express a really detailed set of parameters and then you hope that everything falls into those categories. It's in predictive analytics, the output is a prediction to guide decisions. And so the idea is that it can provide answers you didn't know you were looking for, essentially. This has its roots going back into the 1950s. The first use of machine learning was in the game of checkers. And here's a quote from this article about machine learning. A computer can be programmed so that it will learn to play a better game of checkers than can be played by the person who wrote the program. And at this point, decades later, that seems so obvious as to not even be notable, right? That, well, I could have a software do something that I didn't know the software would do. But this is, because we all know that like chess has been, dominated by computers for many years. It can find answers that no human being could have found in a particular situation on a chessboard. So that's the idea, is that in our work practices, when we're using machine learning, it's also thinking about how we can use these tools to, in many ways, identify outputs that we couldn't have programmed into the software ourselves, right? It has this adaptive characteristic to it. A lot of what drives the artificial intelligence that we tend to talk about, or tools that are labeled as artificial intelligence, whether it's debatable as intelligence or not, is based on this idea of a large language model. So it's a representation of text that's trained with self-supervised machine learning. So by that, we mean that supervised is when a human intervenes and says, here's a bunch of labeled data, here's what a correct association of that string and this entity might be, here's a human being's assessment of whether that really is that person's face, right? Whereas self-supervised machine learning essentially does its own input to do learning to come up with answers to things like, what is an object in a picture, or what is a particular pattern in text. And this is just, a very kind of cartoonish but very common representation of what's going on, is that you have words coming in and words coming out, but you have these layers in between that are kind of hidden to everybody involved, including the developers, about how specifically the input and the output relate to each other. We just know that there's a lot of magical munging of words that ends up identifying patterns that we find useful, right? And so when we use this term generative AI, which is very commonly applied to the tools we use, it's the idea that it can predict the next word, it can predict what the next set of textual responses should be, based on this learning that it does on usually a huge amount of text that's been fed into it, which is why they're referred to as large language models. So if we think of what a model is, right, it's doing a lot of work in this situation, what we're calling a model that feeds into all of this work, right? So a model is something that accurately represents or resembles something else, right, on a small scale, a person or thing that is a likeness of another. It can be a three-dimensional representation. It can be a simplified or idealized description of something, right? And if we think of them being representations, right? A representation is an image, likeness, or reproduction of some manner of a thing, right? Like a US flag can represent lots of different values and ideas, but it clearly is representative of something. Whereas a model, we say it put forward as a basis for theoretical or empirical understanding, or for calculations, predictions. So it's a specific kind of representation of a reality that we're using for a particular purpose, right? And one of the things that's very distinct about the space that we're in now is that whereas in previous decades, a lot of the progress on things we might call AI were on very, very, very domain specific tasks, that a lot of the like ChatGPT and these tools that people are constantly talking about are a bit more generalizable, right? They're a little bit more adaptable to apply to tasks that we hadn't originally anticipated when the tools were developed. So, here's an example, a classic one of a model. This is from the 1980s, the model human processor. And the idea was that testing interfaces on people is really expensive. So how about if we could understand how the brain and the memory and perception works? What are our limits on how much we can remember, and how much looking at something distracts us from what we're thinking about, and basically feed that into a model that they can be used to test the usability of an interface, right? And so that's a very specific idea of a model. It's used to represent how we think a user would be interacting with an interface. So it can be a very useful model, but of course it's also going to have severe limitations because it has all these assumptions built into it. So models are a purposely simplified view of reality, and that's just as true of these large language models as any other model. They just happen to be quite complex. They're valuable for planning and making inferences. There's no single model that's going to be appropriate for all purposes. And really important considerations relate to what attributes in the world to identify, right? What ends up getting emphasized, which to leave either undefined, you just kind of don't sweep them up into a model, or you very explicitly say, this model isn't about those things, so I'm not going to include them in the model. They can have varying levels of detail and granularity. They often serve as kind of boundary objects between users, developers, decision makers, because they represent the problem that you're trying to solve. A model necessarily does, as Bryant Cantwell Smith says, a certain amount of violence to its subject matter, right? Another very popular quote about models is all models are wrong, but some are useful, right? So they're always going to have certain limitations, and that's part of what we have to do going into this work as archivists with our eyes open, is understanding what the strengths and limitations of some of these models are. Determining which attributes are relevant can't be answered just through analysis. We really have to be thinking about what the tasks and purposes are that we're using these tools for. Kathy O'Neill, and a book that I highly recommend if you haven't seen it before, called Weapons of Math Destruction, says to create a model, then we make choices about what's important, what to include, right? Simplifying the world into a toy version that can be easily understood and from which we can infer important facts and actions. We expect it to handle only one job and accept that it will occasionally act like a clueless machine, one with enormous blind spots, right? And as the recent, fanfare, attention, hyperbole around generative AI has developed over the past couple of years, we've become increasingly aware of the great opportunities, but also the blind spots and the limitations of the latest large language models. So two design decisions that are really, really important are if and how to customize or enhance the results to a specific purpose. So something you'll see a lot of reference to more recently in the past couple of years is retrieval augmented generation. So the idea is if I create this huge large language model, on January 1st, 2025, for example, and then I keep applying it, one of the issues is if I'm looking for something about December 2025, it's not going to appear in the response I get from that large language model. So one of the approaches is to essentially have a model that you build from, and then you run retrieval, whether it's a live web search, whether you're consulting PubMed, whatever it might be, that supplements what's in that model. Another question is if and how to update the core model, right? So one example of this is federated learning. The idea of federated learning is, okay, there's a model that's kind of shared and centralized, but I locally don't want to use just that model. I want to use customizations on it. And also, very often, the primary motivation for federated learning is also, I don't just want to dump all my raw data back into the model, right? This has been a major consideration and discussion among archivists and other information professionals, is basically what are the cases in which I can feed all my images, for example, into this model so that they can be labeled in a certain way. And what are the cases where I have professional responsibilities to control access and sharing and aggregation of those primary sources. So I essentially want to run it locally, and anything that I do adapt the model because now it's learning from my own materials, I would like to keep locally rather than feeding directly as raw data back into the model. And so these are kind of a couple of areas that a lot of work is happening now in AI research and development. You can also see this in the tools that many consumers use. And this is not a plug for Google by any means. It's just one of the platforms, Android, that a lot of people use. And many of the platforms that we're using now have this sort of model that they've adopted where you have this core set of tools that run locally on your client that then interact with a shared model that, for example, Google or Meta or whoever is maintaining. And then essentially the idea is like, so for example, if you're using these tools on their phone and you're running against images in your photos, maybe you don't want to share the photo data back to the model. So you want to have this kind of sandbox that runs locally on your own device. There are many questions about how these should be designed and implemented, the degree to which people can and should trust these platforms in various ways. And so that's where a lot of the work is happening, is consumers, are speaking and pushing for models that don't just dump everybody's data into one centralized location in order to use this kind of functionality. Another question is essentially whether you use that one kind of large default model or whether you use a more specialized one. And a space where this is very common in cultural institutions is Transcribus. So Transcribus is used for transcribing primary sources in various, like handwritten, different languages, different historical periods. And it's an area where it's become very clear that simply using one default model against all of the text you might have in your primary sources is just going to be very error prone. And so a big part of this work is often somebody developing a model that's, for example, built on a certain kind of 18th century Dutch records or something, right? And now you know that, okay, if I'm using this to identify entities or to find associations between files that are in that same language from that same historical period, it's probably much better for me to use that specialized model than just a default model that's based on, a bunch of generic English language text, for example. So what kinds of archives and management activities are amenable to AI use? There are a couple sources that I will just reference here. One is from the National Archives and Records Administration. So I've extracted this out a bit because, for example, in enhancing search, if you go to this inventory, they have a handful of different projects that are all related to essentially that idea of how do we enable better search, like end user search over collections by using a number of these kinds of tools. Screening and flagging for personally identifiable information. So for example, I showed you a tool, bulk extractor, that uses a predefined set of essentially kind of rules and scripts to look for certain kinds of personally identifiable information, but you might often want it to be much more adaptable, where you can train it to get better at identifying the kind of PAI that's most relevant to the records that are under your care. Autofilling of descriptive metadata. This is another area where you can find, easily a dozen different projects right now that are looking at how do we enhance descriptive metadata through use of various generative AI tools. Topic summarization and entity extraction. So again, along the lines of what I just talked about with topic modeling and entity extraction, but often taking it to the next level of not just using predefined models and scripts, but actually adapting it to the collections under our care. Freedom of Information Act discovery. Obviously, there are many ways in which we know that FOIA review is challenging, time-consuming, and slow. And so if there are ways that basically that can be sped up and facilitated through some of these tools, that's all the better. Chat interfaces. So this is where a lot of people's minds, I think, who are not archivists, if you ask them about how these tools might be used for archives, their thoughts first go to, well, I interact with chatbots. How might there be one that specifically helps me better interact with, provide reference answers related to archival collections? And then also automated data discovery and classification, right? Review for classification based on different security levels, for example. And presumably the majority of these are going to need a good bit of human in the loop, right? The idea isn't you just automate humans out of these processes, but that you use the tools in ways that'll better facilitate their work. Another source, so these aren't my contributions. These are from a source that you consult from ASIST from this past year. Breaks down some of the application areas in terms of records management, so classification, data collection and management, retention and disposition, right? Identifying records. You saw some kernels of that from the RATOM tool that I was showing you, that you identified this is record content that needs to be retained, this is non-record content that doesn't. Archival processing, they categorize appraisal under processing, regardless of where you put it. Obviously, appraisal is a core archival task that is very much about pattern detection, right? There are many, many ways in which using tools that can help you to better find associations, relationships, and patterns can really facilitate appraisal, arrangement, description, preservation, access and use, privacy, records retrieval, use of records in research, and public access. So those last two are ones that I'm also going to pull out to talk about in particular in just a few minutes. So one of the things to keep in mind is that, as I said, we've changed our definition of what counts as AI over the past, essentially since the 60s, right? It's kind of continued to be redefined what we mean by AI. And just as a kind of example, if you're not an XKCD reader, I highly recommend it. It's kind of like, Dilbert for some of us, right? Like who deal more with geeky technical things. When a user takes a photo, the app should check whether they're in a national park, right? And the person is essentially saying, that would just be too hard, right? This would be a huge research task that I couldn't possibly undertake with just writing a few scripts. You've thrown me a problem that seems really easy to a layman, but a computer scientist will tell you why that's really hard, right? That was in 2014. 2024, you literally have an article saying, haha, that comic that said this was impossible. Here are some like binoculars you can buy that basically just identify and tell you what different birds are, right? And so that essentially things that are sort of on that frontier become more and more facilitated with not just different algorithms, but a lot of this is about core processing power too. Certain things that an analyst or computer scientist could have told you was possible just weren't possible until we threw the kind of computational power that people often are at these tasks. A really important thing to keep in mind is that we're trying to figure out what do we as human beings do in all of this. A lot of the sort of professional preparation that's been introduced recently is around this idea of prompt engineering. So it's basically, how do you sort of do programming, right? How do you essentially come up with a set of parameters that you want to feed into this large language model that'll be most effective, right? So the idea is, just like you learn to be a savvy user of Google by giving it good, queries, how do you prompt these tools in a way that's most effective, right? So this is selecting the prompt strategy, providing clear context, specifying the output format, and refinement based on initial output or comparing results. And you can see a lot of this developing within the archives profession of things like people learning to ask the large language model, if you're telling it to identify certain things in images or in texts, for it to tell you if it's not very sure, right? Because one of the things that large language models generally exude is confidence, and they will basically just give you an answer unabashed about some particular question. And so part of this prompt engineering that we've been learning collectively as professionals is, what sort of specificity and context do we give to these tools so that they will be realistic about the answers that they give us? If we're thinking about the ethical implications, we can think of things like inconclusive evidence, right? So what kind of data gets fed into these models? Is it interpretable? Is it leading us in the wrong direction, right? But also normative concerns, things like what are the outcomes and the effects of the tools that we're using? And then a huge one, as expressed by these authors back in 2016, is traceability, right? So that's essentially provenance, original order, chain of custody, all these things that archivists really live and breathe on a daily basis. So the Berkman Klein Center has a very good breakdown of some of the ethical implications of use of AI, privacy, accountability, safety, transparency, right? All these kinds of things that are related to not just how the tools work, but how do we kind of decide what to feed into them, what to get out of them, and how to interpret it. So principled artificial intelligence, right, has been characterized in a number of ways. And this source from Harvard is the Klein Center also is a very useful one to be consulting. There are a variety of government resources on these kind of issues of what are the ethical implications of applying various AI tools to different kinds of data and different kinds of sources. A couple questions that are really important in broad terms for archivists are how, if, and when we are going to kind of use these tools, right? Appraisal, description, preservation, these things that I talked about. But also, how are we going to best facilitate or not the use by end users of these various tools if we're just thinking about our materials essentially as raw data for their inquiry? So by archivists and other information professionals, this is just a couple very discrete examples. This is one that's more local to, I'm at the University of North Carolina, trying to use machine learning to essentially identify from a whole bunch of statutory language historically, which of it is related to Jim Crow laws, right? Which have the effect of being Jim Crow laws without having to go through and review every single sentence in every one of these documents. And this is the kind of task that's very amenable to machine learning, because you can't just pick one or two words and just do a search for them, right? It actually is much more based on these associations of terms that you can sometimes find with using things like machine learning. This is another very specific example of, for example, if you're doing web crawling and you're trying to identify, you've given, this crawler some seeds and it's grabbed that output and put it into your corpus. How can you use machine learning to basically feed back into that selection and review process? But then by users, more generally, we can think of this whole phenomenon of collections as data, which has been quite popular in recent years, where we're thinking about the fact that we don't have to prescriptively determine all of the different ways in which end users are going to use these tools. Our job is to give them raw data in ways that they can then apply them that are most relevant to their tasks. One of the questions is, how do we use tools to help people learn rather than just answer their questions? This is, again, not a promotion for these specific tools. Very likely a few years from now, these links will break and there'll be other initiatives and other tools, right? It's just to use them as kind of examples of efforts in recent activities to make tools more amenable to people learning from the content rather than just getting an answer. Another really big issue for us as archivists is that large language models, as you saw in that diagram that I showed with the input and output, are not very good at associating specific input with specific output. So there's been a set of kind of tools and initiatives also to better give somebody an answer that directly ties that answer back to sources that inform that answer, rather than the way that a lot of the tools work now. And a general consideration that has been expressed by many people in this space is that essentially we need ways to track the provenance, development, and use of various training data sets throughout their life cycle, right? This sounds very much like what archivists are focused on. So I wanted to wrap up really with a very quick expression of what I would see as some of the dualities, meaning these kind of interplayed but distinct ways of approaching some of these issues related to AI and archives. So what I'm talking about is an opposition, not a simple contradiction, but kind of different takes on the same problem that often we have to find some kind of balance or interplay between. So dualities, often two alternative perspectives on the same problem or issue. They're not just logical contradictions, but kind of two different perspectives on the problem. So what are some of those related to machine learning? One is when we're defining and selecting the training data. So if you're developing a model, how do you feed data into it? Do you do it depth first, meaning you're really trying to get deep into a particular set of materials, or are you doing more breadth first, where you're trying to broadly represent a diverse range of materials? You're representing the common or the surprising, right? Are you essentially wanting somebody to get a result that is going to show them the sort of the average core trend within this documentation, or the things that are actually more outliers? Do you want to perpetuate contextual specificity so people can dig into that source and that origin, or perpetuate more kind of generalizable values and results across those sources? When deciding whether to develop a new model or rely on an existing one, there's just in case, which means basically you want to develop models that are specific to your materials so that you can apply them whenever the problems come up, or are they more just in time, where the models get developed as and when they're needed? Do you explore, meaning you're looking for sort of new ventures that you can identify new patterns, or are you building off the ones that have already been identified in the models that have been developed? Because developing models can be very computationally expensive. When developing and training models and analytical tools, are we looking for sort of coherence or diversity of that representation? Do we want it to be more, you get a simple representative answer that comes from all of these documents, or do you want a more diverse array of representation that is more representative of the edges, but harder to interpret and incorporate into other results? Accuracy and explainability is the primary method around making sure that people can see the whole chain of steps that somebody followed, or is it just in making sure that they get the answer that they need? Internal or external complexity, is that sitting inside of the model, or is it built into the tools around the model? And then do we kind of build these tool chains parallel, like they're all running separately, or serial, where one feeds into the next? And then when preserving evidence of machine learning, do we do reversible or irreversible transformations? So essentially, is there a way to recreate aspects of that model? Do we do snapshots right? Do you basically say, okay, give me a representation of that model at a point in time? Or do we alternatively try to represent just the changes that have happened to it over time? Do we try to kind of reduce down and compress the information so that we can get more definitive results, or enumerate all of the individual values? Do we find a single point of strength, right, where there's basically one model that we are going to provide evidence of, or multiple points of failure, more meaning we're representing a more diverse array of steps in this process? So the final thing I was going to present before I break it to question and answers, I'm very open to any kind of questions or comments you want to share. This is a breaking resource. This was released, I believe, just yesterday. But the AI preparedness guidelines for archivists, right? And so they break down completeness and excluded data, right? So one set of considerations for archivists is around the data that is fed into these models, whether we trust it, whether we think it's representative in ways that reflect what we care about as archivists and caretakers of the records. Another area is around metadata and access. So having item level metadata, this is not something that we can just assume with these tools, that there's actually metadata about each of the sources that the output is associated with. Provenance and relationships. So this is, again, something that requires a concerted effort, making sure that those are represented in the materials that are fed to people and are stored in association with the models. Narrative and discursive metadata, access conditions and sensitivity, all of these things we need to kind of represent when we're thinking about how these models work. Data types, formats, and file structures. So preserving provenance and not overriding it. Aim for consistent formats and derivatives. So one of the real challenges is that each of these tools spit out different kinds of output. It's very, very hard to combine them into processes and activities that archivists use. Using clear and predictable file and folder naming in derivatives. So again, they're more interoperable and you're not just running all these things separately. And then application-specific metrics and evaluation. And again, I'm not trying to speak for the authors. This is an article. It's a relatively short document that you can read yourselves to see how they articulate these different pillars, right? But the idea that we need archive-specific ways of determining whether these tools are actually working for the purposes that we intended, right? And so I wanted to finally just wrap up by pointing out that essentially, right, this is a joint endeavor that we're all engaged in, and that I think both the application of the tools and the learning about them are a shared endeavor that we're all engaged in, but also things like, do we develop specialized models that are for particular kinds of records that maybe we share across archives, or we share methods around how we interact with the vendors of these different tools because we have a common set of considerations about how they use primary source records and how they feed out the output that these tools generate. And so I will stop sharing and open myself up to any questions or comments anybody might have.
Thank you so much, Cal. That was probably some of the best used 50 minutes I've ever sat in on in my life. That was so informative, so chock full of good information. As a reminder, if you have questions, go ahead and put them in the chat. I see we have one from Sean. Has there been a good AI tool that can help read cursive? I know that today's students struggle to read cursive since they're no longer being taught it.
Yeah, and actually, yeah, that was something I didn't really put. I mentioned Transcribus, which has all these different models, but handwriting recognition is actually one area where if you just look up AI in archives and kind of see what a lot of the recent activities are, a lot of work has actually been, because OCR, which is, optical character recognition, where you go through typed text, is very problematic for primary sources because fonts can be different and like newspapers are laid out in different ways, but that's gotten much, much better over the years. The area that a lot more work is really focusing on now is handwriting recognition, which includes cursive, right? And so, yeah, absolutely. That's an area where there's work. The level of accuracy depends a great deal on like how similar what you're applying it to is to the training data, which is again why that Transcribus model is a really interesting one to have in mind, because the idea isn't let's all just jointly try to come up with one uber super tool. It's to recognize that, oh, maybe there's actually cursive writing from, certain record types or certain eras or in certain languages or whatever that has enough commonality that you can actually detect the language. And the only thing I would add to that is also you have to make a determination of like that slider of accuracy and effort. how much is it worthwhile to use some off-the-shelf tool that maybe gets you 85% accuracy, right? Which is around the area, 80 to 90% for a lot of these tools for entity recognition, for OCR, can be in around that range for really sloppy materials, much, much more accurate for really well-behaved materials. But the question is, can I do handwriting recognition on my text and then just present that text that gets output as if it's the primary source, right? And I think most archivists shudder at that idea if we're just basically saying, okay, here's a surrogate, it's a perfect copy of the record because we know it could have errors in it. But if it's being used for an archivist or an end user just to make inferences about the text, or even more commonly to feed search, for example, right? I just want to find entities that I can search for in the text. Very often, the tools that are under development now are good enough-ish with some forms of handwriting to be able to identify enough text to be useful for those purposes, but definitely not good enough to just stand in as a surrogate to say basically like, you don't even have to look at the original because this is an exact copy. It's not really at the point where you could just give an arbitrary handwritten cursive text and have the tools identify a perfect text output, right? But it's definitely an area where there's a lot of work right now, right? Because there's a recognition that, of course, a lot of primary sources are handwritten and not just typed.
Thank you for that answer, Cal. And I'll say too, this is not my field. I'm not an expert in this field at all. But a resource that I found interesting with that is, I don't know if you're familiar with From the Page, Cal, but they just unveiled a new workflow that their whole bread and butter is transcription. And they just unveiled a new workflow that involves Gemini doing that first run through of transcription. And then now volunteers are correcting the AI transcription, even of cursive documents. So Sean, I really encourage you to look at their website for those recorded webinars.
Yeah, and one connection to that sort of work, I mean, that's a great addition. I'm glad you suggested it. Is also we have to think about, I started this off saying kind of we have to think about the use cases we're applying these tools to. A lot of the most recent work on things like handwriting recognition and just text recognition in documents in general is things like how do you crop out the margins so you can find the core text, right? And that's a very generalizable problem in a lot of different kinds of text, but there are a lot of primary sources for which you would absolutely not want to crop out all the marginal text, for example, right? And so it's really helpful to think about what kinds of materials am I trying to represent textually, and is it really feasible to do that? Because a lot of the tools as they're developing now are trying to focus on, the sort of least common denominator problem that they can really make progress on. And like a super messy handwritten document with marginal notes and all that, like that's not going to be a solvable problem for some time, almost by design, because a lot of the tools are actually working on how do you crop out all that noise so that I can better identify the text, right? So like marginalia in particular is something to be thinking about, because the tools as they stand right now are not really designed to deal with marginal notes.
Yeah, that's very, very true. And we have still 5 more minutes. So while we wait for more questions in the chat, I did want to ask you, I'm sure every member of our audience has like varying levels of familiarity with what you've spoken about today. And so I'm wondering, like, for the person in the room that is not familiar at all, maybe a little fearful, but wants to be more informed, do you have a good, I know you shared those guidelines that just came out yesterday, but do you have like a good action point for someone to get started?
Yeah, I think it's kind of in two directions, right? Because there's always sort of the supply and the demand, right? There's like, what do I actually want to do with my work? And then what can the tools do? And I think in my experience with any of the technologies I've worked with for the past few decades, right? It's like you need to get a certain level of familiarity. I think some of those sources I referenced are quite useful for that, of just getting an idea of more or less what are these tools able to do? Kind of what can we learn about what they're useful for? And thinking really concretely about what parts of your workflows, if you're dealing with born digital materials in particular, or digitized content, obviously, what are the parts of your, like, what's your wish list, right? Are there things that you are aware of that are real, we called them in the OSS ArcFlow project, your pain points, right? Like, what is the part of your workflow where you go, and then awful things happen, right? We apply this tool, it works. We apply this tool, it works. And then we get to this thing where it's messy and horrible and manual and we don't really have it solved. There's some times where that part of your workflow might be facilitated by some of these tools. And I think that's where to focus most of the energy is basically what are our workflows and what just notionally, like what would I love for software to be able to do before you then step back into looking at what the tools might do. Because I do think that as much as it's super important to just kind of become informed, go through some tutorials about some of these tools and what they do, it's very easy to get enamored by the possibilities of the tools without really grounding them in like what's most important to our work, right? Like, I guess if in a particular context, like with chatbots for reference or something, right? Like rather than can we just replace human beings in doing reference with chatbots, right? The answer to that is absolutely and declaratively no. But a more interesting question is, are there parts of how I do reference that could really be better facilitated by using some of these tools? Because again, tying it back to that theme I was talking about, they're based on a repeated recognition of a pattern that the software could detect, right? And I think that's the best way to approach these things, because absolutely I do recognize that, you know, not only do people have different levels of technical background, we also have different levels of technical granularity that our job involves. Like some people are off writing scripts and doing the work to actually process the materials. Other people are thinking at a higher level about how this informs the work and how it might better facilitate research. So I would really suggest basically those two things in parallel, just kind of learning how these tools work, right? Some of that is just as a consumer throwing questions at them and realizing what they're bad at and what they're good at. But where I personally would spend most of the energy is around the kind of stuff we worked on in the OSS ArcFlow project of what is your workflow? What would you want your workflow to be? You know, it's something I do in classes a lot at our school, right? Is like have students think about what's a task you would like to perform that's hard to do manually. Is there some way software could help with that? And sometimes the answer is just no. It's just, you know, grubby and hard, and that's why we have people to do it. And a lot of other cases where you can say, wow, I'm amazed that the tools can do these things I didn't realize they could, right? Recognizing objects and images and stuff that 20 years ago they just couldn't do. Well, okay, that's something I can feed into this part of my workflow, right? Rather than falling into these more holistic discussions that we're having as a society of like, is my entire job going to get replaced or not, right? Because I don't think that's a very constructive conversation. But if we really focus on like essentially what are you doing with Born Digital Materials right now and what are your pain points? What are the things you'd like to, are there things that people are coming to you in the reference room asking you that they'd like to do with your materials, and you're trying to figure out basically could some of these tools help with that? I think that's a more constructive approach than just sort of thinking really, really broadly like, how do I have to use ChatGPT in everything I do or whatever, right? Because that's not a very constructive conversation. In the same way that you would just say, how can I use PowerPoint in everything I do or whatever, right? Like that's just a nonsensical question.
I think, yeah, thank you. That's great. And I know that we're at 1 o'clock right now. So if you need to leave, feel free to leave. I do want to try to squeeze in the last question that we have in the chat, if that's okay, from
Sure.
Arlene. What's the outlook for facial recognition? We have over 100,000 images, some scanned, some born digital, but in many cases, we're missing metadata. It would be great to show AI a photo of someone that's known and see if it can find matches.
Yeah. Yep. And, you know, I'm sure many people on this webinar can probably share experiences that they've had with applying these tools to both their primary sources and also their own, right? Just photos on your phone and stuff. That's an area where the software has really dramatically advanced. It used to be that you needed a lot more training data, like essentially many, many more instances of particular faces to get accurate representations. And I would say play with them and see whether the use case you have is actually well served by them, because there are a lot of cases where facial recognition is surprisingly good now. I mean, from the consumer end, it's part of what disturbs people, right? Because you realize like, oh my goodness, they found my face in all these different places. But it really has. And again, if you check with colleagues who've been playing with these tools, you'll probably find some experiences in which it really, really has been very useful to apply facial recognition, because again, it's one of those dancing bear things, right? People get excited by technology when it does something they didn't even know was possible. And just like chatbots answering your questions in a way that you didn't think was possible, things like object and facial recognition have really advanced quite dramatically, right? I mean, they're sensitive to things like somebody's age and the lighting and all those sorts of things, but if you have enough instances, you can generally train them to be pretty good at identifying particular faces in ways that just wouldn't have been possible like 5 or 10 years ago.
Well, that's great, Cal. Thank you so much for coming and talking to us. And thank you all for attending. I encourage everyone to use those links that Marliese, thank you so much for putting those in the chat, that she put in the chat. Be sure to submit your project proposals and workshop proposals for the upcoming SCNA conference by February 13th. And we'll be sure to send out this recording to everybody. So thank you so much, Cal, for coming.
Well, thank you, everyone. Have a great day.
You too.